Good afternoon, everyone, and welcome to another session in the AvePoint booth, AvePoint collaboration booth. So my name is Victor Isakov, and what we're doing in this half-hour session is talking a little bit about high availability from a SQL Server perspective for your SharePoint environment. So we're not talking really about architecting the solution in the sense that, what's the best practice, although we'll throw a few things in. What we're really trying to do in this particular session is help you decide upon what's the best high availability technology to use. So deciding upon a high availability strategy, if you like, there. So a little bit about myself, I'll let you go through that. And again, if you have any questions, obviously talk to me after the session. We've only got half an hour, but feel free to send me an email if you like, connect, whatever the case is. So SharePoint infrastructure, so the SQL infrastructure is very much the bread and butter of what we actually do. So we sort of really know that space really, really well. So again, the genesis for this particular talk is, again, customers and possibly going on a couple of Australian mailing lists and things like that. And I think there's a little bit of confusion about high availability, the different high availability technologies, how they work, those sorts of things like that. So there's a number of different options. So what I wanted to do in the next half hour was just discuss the different options that you have inside SQL Server, what the promise is of the technology, and hopefully that will help you to decide what's appropriate, and then if you need, you can investigate that area further, research it, et cetera, et cetera, et cetera. Again, I do notice in the industry a lot of people do backups, and that seems to work reasonably well, but a lot of organizations don't think about the cost of their SharePoint farm solution, whatever, going down for half a day, et cetera. And it's not particularly expensive these days to implement a high availability solution. So again, a lot of people I talk to have been sort of burnt by what was going on in the 90s. And I'm not going to mention any products or whatever, but the idea here is they had really bad experiences with hardware and software and solutions and high availability back in the 90s. And we've come a very, very long way since then. So high availability is very, very much affordable, very, very reasonably priced. And again, considering the potential cost of the business, if you have things down for a couple of days, something that you should be looking at and trying to convince management, decision makers, etc., of the importance of implementing. So what we're going to do is, again, just some generic points, so decision criteria. Just want to impress certain things on people. So again, we tend to be technically savvy people, we're technologists, and we sort of focus on the technology. But I do tend to notice, again, in the field that high availability is more than just the technology. So there's a lot of management, there's a lot of soft skills, those sorts of things like that. So people sometimes implement brilliant solutions, but something really small and cheap, like a $20 hub or router, is what makes this expensive solution fall apart. So sort of talk a little bit about this decision criteria, if you like, there, and also make some general recommendations towards the end. But fundamentally, what we're going to be doing is just having a look at the state of affairs of SQL Server's high availability technology, which is failover clustering, availability groups, database mirroring, and log shipping. Probably concentrate a little bit more on the failover clustering and availability groups. I want to make sure people understand how that works, how that integrates with SharePoint, the cost to the organization, cost of implementation, cost of maintenance, licensing costs, etc. And then we'll sort of touch upon database mirroring and log shipping and explain. And as we discuss those technologies, you'll see why we're not going to spend a lot of time there effectively. Okay, so focus more on the first two. So let's get underway. So again, with the decision criteria, again, this is not an exhaustive set, but I just wanted to impress on people a couple of things of what are your primary considerations when you're deciding upon a high availability technology solution, secondary considerations, and then also throw into that mix a little bit of SQL Server considerations as well. But just really to ask a quick question, what would you suggest are the primary questions or the drivers, if you like, considerations when you're designing a high availability solution, just to get a little bit of participation? The cost of the solution, yes. Service level agreements, absolutely. Anything else? existing infrastructure? Yeah, absolutely. Everybody's correct, and hopefully we'll expand upon that. And as I said, as technologists, we sort of concentrate on costs, technology, SLAs, etc. But there's also a people component as well, and there's also an importance to engage all stakeholders as well. So if you don't get managerial support, business support, etc., it's very hard to have a high availability solution that works as expected from all the stakeholders. So again, this is it's open to discussion, interpretation, but just really wanted to point out that, it really should be the business that's driving the requirements for a high availability solution as opposed to the technology. So it's not the IT department that should be driving that, it should be the business that is driving this, and the IT department is facilitating this. Because if you don't get ownership, sponsorship, get all of the stakeholders involved, you tend to find that things don't work as advertised. And so just really wanted to impress the need to, engage stakeholders, business owners, systems owners, the businesses earlier on in the piece as possible. To define service level agreements is very, very important, okay? So again, a lot of people talk about the 5 nines. So do you want 99.99% availability, 99.39s, 0.49s, 5 nines? So you can build solutions that are going to be highly available. I think Azure's only promising an SLA of 99.9%, I think. I'm not quite sure there, okay? And the idea here, obviously, the high availability you want, the more that solution is going to cost. So everybody always wants 0 downtime, and then they find out how much it's going to cost, and they say, well, actually, we don't need 5 nines. We can get away with 4 nines or whatever the case might be. And again, it's also important when you're defining the SLAs, it's not just about uptime. It can actually be a bit tricky, so it's also about downtime. How do you define downtime? Because you'll have unplanned downtime because something crashed versus planned downtime because you needed to patch Windows or patch SQL Server. So you had to bring down Windows, that takes time, install patches, maybe do a reboot, etc., those sorts of things. Something that I'm tending to notice these days with hardware is that it's taking a long time for machines to boot up. You can't do anything about that because on your machine you've got half a terabyte of memory, 256 gigs of memory. So when you boot up and it goes through the BIOS checks and the memory checks, it takes sometimes 10 minutes for servers to boot up these days. So again, that might be difficult to minimize, so maybe there's some BIOS tweaks and things like that with the various servers, but you need to take that into account, okay? So again, what do you define as downtime? Is it planned downtime and unplanned, or is it just unplanned downtime? So again, set correct expectations from for all stakeholders, etc. So again, important always to understand the technology, okay? So understand what fundamentally is different with clustering versus database mirroring. Why does one technology fail over quicker than the other? And these are the sorts of things that we'll be looking upon. The other thing that I do tend to see also in the field is that people do a default installation of something and they don't get the quorum model right, or they change something in their cluster or availability groups, and the quorum model should also be changed as well. So the quorum model decides what servers should be up, what servers should be down, whether the whole environment should be up or not. So in certain cases, if you haven't configured it correctly, you might have 5 servers together in some sort of high availability technology. We'll genericize it, but 2 servers will go down or 1 server will go down and the whole thing will shut down because it can't reach quorum. It can't decide what's the state of affairs. So again, just concentrate on making sure that you understand the quorum models and how they work with the different high availability technologies, because things might completely shut down because of a simple misconfiguration inside your environment. And the other thing with high availability is that people, again, the classic story is forget about the simple things. So you need to think about redundancy at every level. So you've bought these servers for tens of thousands of dollars, great kit, but you're going through, one switch, which is a couple of $100. So there's no network redundancy, etc. So you need to take into account the whole stack, if you like, there, from the data center to people to processors, all sorts of things. Because at the end of the day, you're trying to predict all the possible things that can go wrong and mitigate against that, if it's cost effective. So it's a risk assessment, if you like, there. So secondary considerations, and again, you design the best solution, but if you don't have people that can operate it or know what will go wrong if X happens or Y happens, things fail in that particular context as well. So the ease of implementation, the ease of administration, of course these can be mitigated against with training, research, etc., etc. But again, you need to make sure that you've got a solution that you can actually implement and can be used by the infrastructure people, whoever are running it, etc. Something that we're not really covering inside this particular session is also, or has to do with remote blob storage. So what you can do in SharePoint is externalize all of your blobs into a secondary external store. So we're not storing them in content databases because they're quite expensive in terms of storage. They typically tend to be tier 1 storage. So again, what are you going to do there? Okay, we're not covering it, but again, you've got some considerations there possibly to look at if you're going down the RBS path. So just a couple of things with SQL Server considerations. So just again, keep this in mind. Availability groups are only available in the Enterprise edition of the product. SQL Server Standard Edition for a long time has only supported 2 nodes in a failover cluster, but that is more than sufficient for a lot of people. The other thing I'd point out is that, again, as with the previous slide, presentation that I discussed, Standard Edition only supports 64 gigabytes of memory. So if you've got a machine that you're planning to use for clustering and it has 256 gigs of memory, maybe you can install 3 or 4 instances of SQL on that machine. So there'll be multiple instances of SQL running on a 2-node cluster. And then you can start to put content databases and service databases into different instances, etc. So again, think about those sorts of solutions as well, because hardware has become so affordable, if you like, there. The other thing, if my memory serves correctly, is that the DR licensing has changed, DR high availability, whatever you want to call it, licensing has changed in SQL Server 2012. So in earlier versions of SQL, you could have multiple sort of standby servers and you didn't have to license them, whereas with 2012, you can only have one. So the idea here is you might have an office here in Gold Coast with 2 servers, another server in Brisbane, so you've got a local failover node and another remote failover node in Brisbane, but you're going to have to license one of those now in 2012. In early versions of the product, that wasn't quite the case, okay? So this is just a little bit of a summary for you. So again, this is the technology that we're going to go through. So I've just sort of listed here what's the recovery point objective here. So how much data loss can you afford there? The recovery time objective there. So effectively how long it's going to take to recover the system if things go wrong on one of the running nodes, if you like. Do we have automatic failover? Sometimes you don't want automatic failover. So there are also business cases, business reasons for that as well. Technically, can you also read the secondary? So you have multiple systems. Can you actually read the secondary environment? Now, SharePoint might not work with it. We're not talking about SharePoint. We're just looking at the technology in this particular case. And also the minimum SQL Server edition and version as well over here. Just a couple of points. Notice over here with log shipping, there's a star. So again, there's some considerations there, and also with database mirroring, I've just put an asterisk there. So again, we'll talk a little bit about these things coming up, but there's some serious caveats with that. So the first thing that I want to talk a little bit about is failover clustering. So have a look at how the architecture works so you can get a sense of how the technology works, what kind of hardware you need to buy, and how it runs and what expectations you can have from it. And then we'll discuss the pros and cons, and then we'll repeat this for the other high availability technology. So again, there's lots of bad acronyms and terminology used in the industry with active, passive, active clustering and all sorts of things there. Again, Microsoft are trying to discourage people from using that terminology, but it just is persisting. But again, the idea behind a failover cluster, a couple of things. So you can see that in this particular case, you have 2 nodes. So you have 2 servers that are going to be running in this cluster. Let's forget about virtualization. And the other important thing that you'll notice is that you have shared storage. So it could be direct attached storage or SAN technology, but you have shared storage somewhere. And the idea behind clustering is that SQL Server is installed on both nodes, so the binary files, DLLs, etc., are installed on both nodes, but they're only ever running on one of the nodes there. So that's the active SQL Server instance that's running on that particular node. So in this particular case, you can see that node 1 is sort of connected to the shared storage with that arrow. So the idea is SQL servers running on this particular node. And the idea here is if something goes wrong with node 1, so the hardware fails, SQL Server crashes, SQL Server hangs, etc., the idea here is eventually what will happen is node 2 will detect that particular condition. So we have to meet quorum. So in this particular case, it's node plus disk majority, and there's different quorum models. But the idea here is you have one node, you have a second node, and you have a third disk quorum. So this technology will decide that SQL Server running on node 1 has failed, so it's time to start up SQL Server on this particular node. So that's how it actually works, okay? So running on this node, not running on this node. Now again, if you're familiar with clustering and do a little bit of reading, etc., you'll see a lot of diagrams that talk about private and public networks and things like that. And again, a couple of years ago, I would have drawn this diagram with two Ethernet connections or whatever. So one with public, one with private. I didn't in this particular case, hoping that it might raise a question or people are thinking, okay, why, is he being precise or not? I just wanted to point out that things have changed a lot in clustering. So what you might have done with clustering in 2008 even has now changed in 2012. So the technology has evolved a lot since earlier versions. They're really spending a lot of energy in clustering with the Windows Server team there. So 2012 is a vast improvement on 2008 R2. 2012 R2 has a lot of improvements in the clustering technology, how it works, resilience in the cluster and those sorts of things. So be careful of applying old practices or designing a cluster today with best practices and recommendations from 5 years ago, because they're no longer best practices. Okay, so just be careful with that. So that's basically the architecture of clustering, and hopefully that explains some of these things. So with clustering, the pros are that we have automatic failover. Okay, so if something goes wrong, it automatically fails. Now that actually isn't correct. I was at a customer site 2 weeks ago, and literally something went wrong on the network and the cluster node was not failing over due to the way it was set up and a few other problems with the network and those sorts of things. But that is the general idea. So if something goes wrong, it detects that the disk's offline, the network's offline, servers crashed outright, SQL servers hung. So the idea here, it should fail over. Later versions of SQL Server do a better job of detecting, and you can customize that as well. So it's not something has crashed. You can sort of set up, if we have 20 serious errors occur in the last 24 hours, then fail over, things like that. So it's again much more complicated, a richer environment if you like in the later versions of Windows Server. Generally fast failover, okay, but it really depends on what has happened. So, we sort of used to say at conferences, failover clustering is going to take, 30 seconds to a minute or a half. It really depends on what has gone wrong. Because if the right combination of things go wrong, some sort of an error occurs, SQL Server can't do something to the disk. It's going to retry a couple of times before it decides that that disk is dead. So that's going to take time. Then the clustering technology has to talk to SQL Server to say, okay, something's gone wrong. So the failover might not actually be as quick as you think, because the detection, depending on what has failed, can take quite a long time in computer terms. So it can take a bit longer to fail over than you expect. Okay? And then also, as I said, the problem with clustering, or the issue with clustering, is that SQL Server isn't running on this node. So when it starts up, it's going to take a little bit of a while. Then it possibly has to recover the databases by scanning the log over here. So again, the failover might be a bit longer, and it'll be variable possibly as well. Okay, and then again, that little point about biases on machines as well. The really great thing about clustering, I wasn't a big fan of it before, but I am now, is that it is really, really easy to maintain. If you need to install patches for Windows, for SQL, for SharePoint, again, depending on how you've set things up there, it is really, really easy. So you patch the node that it has nothing running on it, and then at some point in time you fail over, then you patch the other node that now is not running anything in that particular context. So very, very easy to maintain. The other nice thing about it is that you've got this centralized location for all the databases. So all the content databases, the SharePoint databases, but also the SQL Server system databases as well. So in that particular case, you don't have to worry about scheduled jobs, logins, etc., because they are both being accessed by the two different nodes of the cluster. So you don't need to synchronize anything. You create a login, you create a scheduled job, it'll work on node 1 and node 2. So very, very easy from that point of view as well there. It's also very, very easy to set up with SharePoint, okay? Because what clustering does is it virtualizes the server name. So it virtualizes the IP address. So the two nodes have their own physical name and net BIOS names and IP addresses, but you've got a virtual IP address and a virtual network name. So it's really, who are you connecting to, which node? So it's taken all, clustering takes care of all of that for you, okay? And the other nice thing is that the databases can use any recovery model. So whether it's full or simple or whatever, it makes no difference in this particular case there. What are the cons of clustering? Well, probably the biggest con is the shared storage. If that shared storage goes, if that fails, and obviously you have RAID 5, 10, some redundancy there, but if that goes, then you're in trouble because you don't have redundancy at that level there, okay? You've got redundancy everywhere else, but you don't have redundancy by default with shared storage. And that's why sometimes people combine high availability technology. So people have clustering, but then they might combine it with database mirroring or log shipping or whatever the case might be, okay? There's obviously hardware solutions there as well, so there are different things there. But again, that's your weakest link, so how are you going to mitigate that if it is a big enough risk in that particular case? So there's no redundancy at that shared storage level, if you like, there. It's not a scale-out technology, so you don't have multiple nodes running and scaling out. So it's not a scale-out technology. SQL's only ever running on one of the nodes of your multi-node cluster. Okay, so it's not a scale-out technology, so you're not going to improve performance there that way. You can also have geo-clustering. So the idea here is you have two nodes here again in Gold Coast and another node in Brisbane. So you can have a geo-cluster. There have been improvements in the clustering technology. So you can see SQL Server 2012 supports multi-subnet failover clusters. And again, that's dependent on Windows Server as well. But typically what you need with a geo-clustering or stretch clusters, as they're sometimes known, is a hardware solution as well. So possibly something like SAN replication. There's different technology there as well, okay? Poor man's geo-clustering, log shipping to the other side, things like that. So that's a really simple technology that you can use. Now this again I've put in italics at the bottom, so again it depends on a number of factors, but typically failover is not as quick as availability groups, which is what we're looking at next, and hopefully we'll explain why in a short while. So the next thing that we want to look at is availability groups. So again, the architecture, the pros and the cons. So this is what our availability groups look like. So these first of all were introduced in SQL Server 2012. Now with availability groups, again forget about SharePoint, just looking at the architecture, you can see that we have now multiple replicas, what we call replicas. So we have our primary replica sitting over here, and then what we're doing is we're replicating the databases to two secondary replicas in this location, and then in Melbourne and Brisbane, we've got another replica as well. Now the full line over here indicates that we're using synchronous replication. So the idea here is that the databases on all three of these particular servers should be exactly the same. Okay, so we use synchronous communication between those three particular replicas. However, because of the performance of the WAN links, the latency, the bandwidth, etc., in Melbourne and Brisbane, what we've done in that particular case is implemented asynchronous replication, okay? So there might be a little bit of a delay between data changing inside this particular database and this database over here. There is potentially data loss if all of this fails and you haven't replicated to this in time in that particular case there, okay? Now, availability groups, as I said, is only available in 2012, and the really cool thing about this particular technology is that it is potentially scale-out technology, because what you can now do with availability groups is that you can run reports off the secondary. So you can say that a secondary replica is readable. So you can see that in Melbourne, Brisbane, and where is that, in Sydney, they're doing reports, they can run reports. So you're sort of improving performance because you're not hitting the primary server for that. So the reports are run off the replicas, the secondary, and the main OLTP, the modifications to the database, are run against the primary system over here, the primary replica. Notice you can also offload certain operations such as backups or database consistency checks. So again, we're performing backups of this particular replica number 3, which means again, we're not impacting the server, the memory on the primary replica in this case. And notice again what I've done with this diagram is I've set up automatic failover from this particular primary to replica number 2. Okay, so that's something goes wrong, we fail over here. Okay, now with this technology, yes. Yeah, so you specify which is the failover partner. Okay, so you don't again have to. You don't always have automatic failover, but you can, and if you can, you have to specify one. Okay. Now the thing here about this is that you'll notice is that SQL Server is running on all 5 machines in this particular case. Unlike clustering, we had 2 pieces of hardware, but you only ran it on one, and that was the active one, okay? In this particular case, you've got SQL Server running on each one, and you also have a copy of the databases, a replica of the databases. So now you've got, as you can see, redundancy at the storage level as well. So every one of these SQL servers will have its own version of all of the, the service databases, the content databases, its own databases and those sorts of things there. But then it obviously adds complexity. Questions will have to be quick, otherwise we'll be... So for the asynchronous node, is it a...
No, when there is a low latency.
Yes.
Asynchronous, the replica file will take a long while to get updated. So is that backed up on the transaction log?
Sorry, for this one? Well, for this one over here, the backup of the log? Well, you'll see that there are some restrictions on backup, so not everything is possible, okay? But with asynchronous, it will eventually catch up. But if the link goes down for a while, you'll see that there's a backlog, and it queues the operations, and then it tries to flush them through. No, it's in the technology itself. It's in the technology of SQL Server. It's sort of reading the log. So this all works by sending buffers of the transaction log across the network. So as we harden the transaction log in 60K chunks, we write to disk, and then we try to write that buffer across the network to the other. So there's another pool of memory and threads that are working with that. So we harden, save it to disk, and then we try to ship the buffer, okay? And when we know that it's been done on all the others, we can remove it from that buffer pool, if you like.
Licensing implications.
The licensing questions. I can't... so this is where, in this particular example, you have one free license for DR. Okay, that's replica number 2. Everything else would have to be licensed. I can't say too much more. Okay, I can talk offline. So this is fundamentally how the technology works. And this hopefully also explains some of these pros and cons. So notice that with availability groups, what we do is we define a container of databases. So databases fail over as a group, okay? And this was a very important feature because products like SharePoint, TFS, it's not one database that needs to fail over, it's a group of databases, there's an interdependency between them. So when you set this up, you basically set up a container, an availability group, and then you fail over that unit, if you like, to the other replicas over here. So again, we're not going to go into a lot of best practices, but you can separate the content databases from the service databases. There's issues with asynchronous versus synchronous, etc. With SQL Server 2012, you can have up to 4 replicas. Okay, so 1 primary and 4 secondary. In SQL 2014, they've increased that to 8. Okay, so there's some enhancements there. They've also improved the performance and a few other things there as well with 2014. And as you can see, you can offload certain activities to the secondary replicas, such as database backups, copy only is the caveat there, transaction log backups, and database consistency checks. But you probably then have to pay a license. So that can be an expensive proposition for enterprise edition. It depends obviously on SA and enterprise agreements, etc. So again, just that point. Automatic failover, generally fast failover. It's going to be faster than clustering, all things being equal. So again, I've put that in italics because again, we don't have to bring up SQL Server. We don't have to go through the automatic recovery process. SQL Server's running. We're doing things across the network, and then it should fail over much quicker. Okay. There's no shared disk, as we discussed. And then again, you've got this option of asynchronous versus synchronous commit there. So with automatic, it requires synchronous. Better for remote sites to use asynchronous. The service apps databases don't support asynchronous from memory, so it's the content databases that can use asynchronous. So there's a few gotchas there for SharePoint, if you like. But we do, in theory, support readable secondaries. If you look at the cons, SharePoint 2010 Service Pack 1 and 2013 doesn't support the full gamut of features, okay? And that fundamentally is because as Microsoft is developing SharePoint and SQL, they're sort of out of cadence, as I call them. So, they released SharePoint 2013, and Microsoft have just released SQL Server 2012, so they weren't able to work with 2012 at the time that they were developing SharePoint 2013. Okay, so it's typically the next version that can fully utilize the features of a release of SQL Server. So that's partial explanation. So the idea here is you do have read-only access or readable secondaries, but in general with this technology, what you can do is you can actually have an application connect to the primary and automatically get redirected to the secondary. So it can automatically do that. But unfortunately, SharePoint doesn't work that way. So for all intents and purposes, SharePoint doesn't natively support the readable secondaries. But I believe people have gotten around it by creating a separate SharePoint farm and pointed to that read-only secondary. Okay, so those sorts of things can be done. Trevor.
If you did something like that, what would happen if you failed over that? Your read-only cycling?
Trevor, I'm looking forward to your blog entry on your experiences of this exercise. Okay, so of course you wouldn't have automatic failover going to something like that. So you'd need to be, there'd be manual processes involved of shut it down, things like that. Okay, so it's a lot more complicated to set up with SharePoint because again, the logins aren't automatically everywhere. So you need to synchronize things, service accounts and those sorts of things, etc. compared to clustering. Requires Enterprise Edition. And again, as I pointed out, you can only have one DR replica for free. So let's now move on to database mirroring. I'm not going to spend too much time here and you'll see why in a short while. So again, look at the architecture pros and cons. Availability groups is an evolution of database mirroring. So in SQL Server 2005, we had database mirroring, okay, and that's evolved into availability groups. Availability groups is actually a combination of database mirroring vNext plus clustering. Okay, so it uses the clustering technology to detect failover and do quorum, but it's using the database mirroring technology of shipping the transaction log buffers across the network. So the idea here is that, again, you can still possibly use this, okay? So let's talk a little bit about that. So with database mirroring, it was a much simpler architecture. You had one machine which was a principal and a second machine which was the mirror, okay? And if you wanted to have automatic failover to form quorum, okay, so detect a condition that would trigger a failover, you also have a third machine which is the witness, a third SQL server. Now that machine could be an Express edition. But again, you hear horror stories of people, installing SQL Server Express on the receptionist's PC underneath the counter, and then of course he or she shuts that down, and etc. So again, you don't have to have Enterprise Edition or Standard Edition for that, but you still need to do something fairly serious with that, because if this isn't working, then none of this technology is going to work. Okay, so very, very similar in the sense that SQL Server is running on both of these machines, and you're synchronously or asynchronously shipping the transaction logs. So if you look at the pros, automatic failover, generally fast failover, faster than failover clustering, so very, very similar to what we saw with availability groups. Available in Standard Edition is probably the big difference. The downside of database mirroring is that officially it is deprecated. So Microsoft are going to drop it in a future release. Now that's not good story. That's not a good story for Standard Edition customers. So we don't need or can't afford Enterprise Edition, but we need a better solution. Can you have availability groups but only have one replica? So at this point in time, no. 2014, I could bet my house on it, no. But at some point in time, they're going to have to address this particular state of affairs there, okay? So the idea here is you still can use the technology. Again, let's have a look at the cons. So you require a separate SQL Server instance. It's implemented at the database level. And that's why they came up with this evolution into availability groups, where it's a container that fails over. So you might have a simple solution, a SharePoint farm, where you want all your content databases, service databases to fail over if one of them goes wrong, if one of the disks of many that you have, okay? So the idea here is it's implemented at a database level. So if one database fails over, what are you going to do? You're probably going to have to script or do something that fails all of them across. I mean, it depends on your architecture in that particular case there, okay? So the other problem is that it's a bit more complicated to set up with SharePoint. So similar constraints with logins, jobs, and those sorts of things there, okay? So that's probably it. The other thing, I think I've got some more cons. All the databases need to be in full recovery model, and that's also the same for availability groups, which is a bit of a problem because the search databases and things like that can generate a lot of transaction log activity, okay? They made some enhancements in SQL 2008 versus 5 with that, but again, hopefully you're not using 2005. So you can only have one mirrored database, so not multiple replicas as you saw with availability groups. You can't really access the mirrored databases. You can in theory by taking a manual database snapshot and accessing that, but it's not really a viable solution for most people. And the other thing that they found was that performance suffered because again, people use the technology beyond what Microsoft was envisaging. So Microsoft made some recommendations. I'm not going to repeat them because they weren't quite technically correct. But then people started to implement database mirroring with 400 or 500 databases. And then it wasn't designed for that. Okay, so you'll find on the web that the more databases that you mirror, the more threads you have that are dedicated to doing the database mirroring per database. And that was the problem. So they completely changed that in availability groups there. Okay. So finally, just to finish up, we're looking at log shipping. So log shipping has been around for a long time. I think somebody invented this and Microsoft said, oh, this is a really good idea. So they put that into the product as a feature. It's really quite simple. You have automated tasks that periodically will back up the transaction log, copy it across to another server, and load into another server. The great thing about this is it works. It's really using primitive concepts of backup, copy a file, restore a database. If there's any problems in any of these technologies, you shouldn't be buying the technology. Okay? So again, you can see that it's a much more manual process, or you can obviously schedule this, but it's not going to do anything automatically for you. So this is a great technology for off-site DR. Okay, so you're periodically backing things up over here in the Gold Coast to some other server or share or onto the SQL server. Then again, periodically copying things across the WAN link to Brisbane. Possibly the WAN link is down. Who cares? Next time it's up, it'll complete the job at that particular point in time. And then you load it into the other system there. So it's a great technology for off-site DR, okay? Doesn't require fast networks, fast throughput, so again, doesn't require low latency. You can schedule it hourly, daily, every minute if you want there. So that's also good technology. Oh, somebody did a mistake. They accidentally deleted the entire site. Oh, that's okay. We've got that sitting in the Brisbane office there, because you might, for example, be doing backups hourly, but you do the log shipping at the end of the day. So now you've got a 24-hour opportunity, a window effectively, to roll back that particular operation if you like there. Okay, so again, very, very good technology for those sorts of things. So that's the last point there, great for recovering from user errors. So nothing's crashed, somebody's made a mistake, somebody deleted a table or data, something inside SharePoint, you can recover that quite easily. Okay. The cons, well, it's not an automatic failover technology, okay? It's not going to work like the other stuff that we've looked at. So no automatic failover. And again, you wouldn't do this, but you can set it up, but manual failover is complicated. Failing back is even worse. So you wouldn't use it as a failover technology in most cases, given the cost of implementation, how easy it is and cheap to implement the other solutions there. Databases can't use a simple recovery model because they need a transaction log. That's what it's relying upon. And again, you need to take into account your backup strategy here because you're doing backups. So you just need to make sure that they sort of integrate well with whatever you're doing, agents, those sorts of things there. So just some general recommendations to finish up. Make sure you design appropriately as always and test redundancy of every component. So it's not just installing SQL or clustering, whatever. Pull out the network cable, put an axe through the switch, buy another one, etc. So the idea here is test every component of your high availability solution to make sure it's going to work how you're expecting it to work. As I say, things always work on the whiteboard, always work at conferences mostly. But you implement and then something weird happens there. Try to always use the latest version of Windows, especially for clustering, but also availability groups. So you'll find that the technology has improved a lot, okay? Things will not all shut down automatically because of certain combination of events. So you've got something called last man standing in the latest versions of Windows clustering. So as nodes go down in your cluster, it won't shut down the entire environment there. So standard edition, as I keep saying, 2012 R2 is the way to go. Don't implement this on 2008 and R2 if you can. Make sure you install all the latest hot fixes for clustering. So both for availability groups, because they rely upon the clustering, DLLs, XCs, etc. Make sure you install the latest hot fixes, patches, and those sorts of things there. There are substantial improvements in performance and reliability of clustering in that particular case there. And then, of course, something that we really didn't cover too much in, understand what complexity SharePoint brings to the environment. So how the databases work, which ones can be clustered, what's the recovery models, what do you need to change, what logins you have to create, jobs, and those sorts of things there. So just some general recommendations there, and I think that's basically it. So thank you very, very, very much for your time. We'll take some questions after this, and please fill out an eval to win a sculpt mouse, but it would also help me anyway. Thanks, guys.